All right, this is target 2E, interpreting functions. Now, again, this is something we've kind of done, and it's not any one place in your book, so we're going to be kind of all over with it. All right, so let's get started. This is all going to be about real-world functions. So we're going to take some real-world situations and show how you can use functions and graphs of functions to help interpret data, as well as to be able to identify the domains of these functions. All right, first example I'll use is video games. The number of hours people in the United States spent playing video games each year from 1998 to 2001 has increased by 11.9 hours each year from its original measure of 46.4 hours in 1998. So we need to create a function that models this information. This is similar to what we did before when we had to write equations from word problems. The only difference is you don't have that big number that would be your y value if we were to set this up as, y equals mx plus b type of equation. So basically what we do is we look for that kind of variable indicator, that word that tells us that this is the value that goes with a variable. So this each is what tells us that it's 11.9 hours each year. Remember, when it says each or per, or it's a number that's changing, that's the one that's going to get the variable. And there's 46.4 hours. That's your starting point, so that's your constant. That's what doesn't change. So that's how I came up with this equation here. F of x equals 11.9x plus 46.4. All right, so let's graph the function now that we have the equation and identify its domain and range. So we start with the function from the previous slide. You can identify then where the line should start. That's the b part of mx plus b, okay? That's the y-intercept. That's where it starts on the y-axis, where it crosses the y-axis, and how much it increases or decreases. That's its slope, or the m part of the equation. Remember, slope is rise over run, okay? And if run always goes right, and the rise part goes up if positive, and down if negative. All right, so let's take a look at this graph. So again, we started at 46.4, which is right there. Okay, our equation, remember, was the f of x equals 11.9x plus 46.4. Okay, and our x-axis is the years since 1998. Okay, that blue line represents the hours playing, and our y-axis is the hours spent playing. Okay, so if we were to look at this and say, okay, so it should go up. Now you've got 11.9, and we'll put it over 1 since it's not already a fraction. This is positive, so it goes up 11.9 and right 1. So we went up 11.9, so that would be about 58.3. So that's about where that is right there, and that's after 1, okay? And then if we did it again, it'd be at about 70 hours. So again, this is our graph, and the good thing about a graph is you can just look at it without having to plug numbers in and say, okay, I can kind of see where we're at after 1 year, after 2 years, after 3 years since 1998. So you get the idea from that. All right, now we would move on to the next part and say, okay, now let's say I asked you to find the value of f of x when x equals 2. And in terms of the problem, explain what they're asking, okay? So basically, we go back and we look at this and say, okay, when the f of x is 2, we're right at about 70. All right, now let's plug that 2 into our equation and see, because we had this. Remember, this was our function, okay? And we're going to plug 2 in for x, so when f is 2, we've got 11.9 times 2 plus 46.4. So that is 23.8 plus 46.4. So when the domain is 2, because remember, this is x is the domain. So when the domain is 2, we're at 70.2. And that pretty much matches up with what we have right there. We're right at about 70. So as far as what they're asking you to determine, that would be, it's been 2 years since 1998. So in the year 2000, people are playing video games an average of 70.2 hours per year. So you would go ahead and you would write that out, in 2000, people play an average of 70.2 hours of video games each year. All right, so that's basically how you would answer that problem. All right, now let's say we wanted to find the value of f of x when the f of x equals 60. So now, remember, we're saying the f of x equals 60. So now we would turn it around and say, well, 60 equals, because that's the f of x, our original equation was this, remember? F of x equals 11.9 x plus 46.4. So we would turn that around and say, okay, now we've got 60 equals 11.9x plus 46.4. Okay, so we would subtract 46.4 from both sides. Okay, it would cancel out over here. Over here, you would have, let's see, that's, it looks like about 13.6. My math is hopefully good there. And then we would divide by 11.9. Okay, and let me just go ahead real quick and plug that into my calculator and see what we come up with. So we've got 13.6 divided by 11.9. And what you come up with is, rounding to the nearest hundredth, and that, so since that's not exact, we say about, x equals about 1.14. So what this is different, how this is different is now they're kind of asking for you to find that range, okay? They haven't given us the domain, we're being asked to find this range. Actually, they've given us the range, we're being asked to find the domain, what x is. So how that's different is, instead of asking us how many hours of video games we're playing, at a certain time, now we're asking how long is it going to take to reach an average of 60 hours of video games a year. And basically from 1998, we would say it would take, starting from 1998, it would take about 1.14 years to reach an average of 60 hours of video games a week. Okay, so basically what's happening is we're saying, okay, before we were being asked for the domain, and I'm just going to go back, 60 hours of video games, I'm going to abbreviate, in a year. Okay, so I'm going to go back real quick. Okay, so in this equation, they're asking you to solve this right here. Okay, f of 2 equals 70.2. And that was our notice that corresponded to our y-axis, okay? So it gave us a domain, it asked us to find the range, which is along this y-axis, so that's the hours spent playing. Then you go to this equation, they've given us the range, and they want to know, okay, now what's the domain? When are we going to hit that point? So 60 is right about there, and that's about 1.14. Okay, so now that's the years since 1998, which is how we answered the question. Starting from 1998, it would take about 1.14 years. So when they give you the f of x, you're basically looking for the value along the x-axis. When they give you an x, you're looking for the value around about, with regards to the y-axis. A little confusing, but you'll get the hang of it as we do more. All right, let's take another look at this. Carlos, Candace, and Bill all go to the movies. That day, the theater runs a special where all concession stand items are the same price. Carlos buys 3 items for $5.25. Candace buys 2 items for $3.50, and Bill spends $7. Create a function that represents this. And I should have added in, my apologies, Bill spent $7 on 4 items. All right, so how do we figure out how much each item costs? Well, you can add all 3 of them up and divide by the number of items that it says. Okay, 3, 2, and 4. So if you took $5.25 and $3.50, that would give you $8.75, and then the 7 would give you $15.75. And if you divided by, let's see, 4 and 2 is 6 and 3 is 9. If you divided by 9, you'd get $1.75. The other thing you could do is you could just take one of them. This one would probably be the easiest, the 2 for $3.50. Say, okay, that's 1, and that's 75. So I know that each item costs $1.75. Okay, so, and notice there is no, plus B. Where did that go? Okay, there was no base amount that wasn't being changed, so that wasn't in there. If you had to include it, you could say 1.75x plus 0. Okay, if you had to include that, but because plus 0 doesn't change anything, we just use this right here. Okay, so that would be your function for that. And since that's all they're asking you to do, that's all you would have to do. Now, if you were asked to graph it, could you? Okay, so we've got our graph here. Cost in dollars and cents, the number of concession items. So where do you think this is going to cross the y-axis? Where do you think our line is going to start? Well, remember, this had this invisible plus 0 here, and that B is your y-intercept. So that means it's going to start right here. And since it was 1.75x, that's our slope. So our slope is 1.75 over 1. So if I've done this right, it should go up 1.75 and then over 1. Now notice these go up by 2 and these go over by 1, so that's why it doesn't look like exact. But it should be somewhere in this area if this graph was done correctly. And then 2 would be 350, so that would be, this is 3 right here, so 350 should be somewhere in this area. We said that we determined that 4, that was $7, so that should be somewhere in this area. Now notice those points form a line, hence it's a linear function. So let's see how I did here. Bam, right through them. So, and you can easily tell about how much each one would cost. Well, if I got 5, we're right around here, so it looks like a little less than 9. Now 6 looks like, between 10 and 11, so on and so forth. It looks like if I got 8, I'd probably be right at 14. So again, graphs are an easy way to interpret that without having to plug the numbers in and figure it out.